Hello again. Welcome to Geometry Section 3.6, Perpendicular Lines and Distance. Let's talk about parallel and perpendicular postulates. The parallel postulate states that if there is a line and a point not on that line, then there is exactly one line through the point parallel to the given line. Okay, our picture can illustrate that. We have our point P and we have the blue line, so the blue line exists first. We have a point P that is not on that line. Therefore, the parallel postulate states that there's exactly one line that goes through P that is parallel to the original line. Okay, pretty straightforward. Same thing is true with perpendicular lines. Perpendicular postulate states if there is a line and a point not on that line, then there is exactly one line through the point and the point perpendicular to the given line. Our picture, again, we have point P that is above and not on line, the blue line, so therefore then there exists one line, the red line, that goes through P perpendicular to the blue line. Again, the parallel and perpendicular postulates. Some more definitions. Distance between a point and a line. The distance between a line and a point not on the line is the length of the segment perpendicular to the line from the point. What is that saying? Basically, it's saying that the shortest distance, which is the distance that we talk about, it's always the shortest distance, from a point to a line is a perpendicular line that goes through that point. So we have to have perpendicular lines to measure distance between objects. Next key concept, we have distance between parallel lines. The distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other line. So we can take any point on one of the lines, draw a perpendicular through that line to the other, and measure the distance. Lastly, we have two lines equidistant from a third. It says in a plane, if two lines are each equidistant from a third line, then the two lines are parallel to each other. So if we have three lines that exist in a plane and the outside two are the same distance from the inside one, then the outside two have to be parallel going through. Alright, some more postulates on perpendicular lines here. Theorem, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. And we will prove this theorem later. So we have a linear pair that with the two lines created, G and H. Since they are congruent linear pairs, we have perpendicular lines. And again, we'll prove that later. Theorem, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So if two sides of two adjacent acute angles are perpendicular, then the two angles are complementary, and we will prove this theorem later as well. Lastly, one that we probably already know, if two lines are perpendicular, then they intersect to form four right angles. Okay, four right angles. So looking at perpendicular lines in our theorems, we have if two lines intersect and they form a linear pair, they're congruent angles, then we have perpendicular lines. If two sides of two adjacent acute angles are perpendicular, then we have angles are complementary. And then lastly, two lines are perpendicular, they form four congruent right angles. Alright, let's take a look at one of the proofs. Okay, we will know these proofs inside and out for our test on this section. So given BA is perpendicular to BC, prove that 1 and 2 are complementary. To prove that we have complementary angles, we must show that angle 1 and angle 2 add up to 90 degrees. Given only what we know from perpendicular lines, we must show then that 1 and 2 are complementary. We start, of course, with the given. Okay, BA is perpendicular to BC, given, and all we can use is that given. So what does it mean to be a perpendicular line? What does that do for us? Okay, if we look at our labels, if we know we have perpendicular lines, we have right angles. So therefore, angle ABC, that's angle A to B to C, is a right angle. So we have this angle being a right angle. Well, we know that reason. Definition of perpendicular lines is what it means to be a perpendicular line. You form a right angle if you are a perpendicular line. Alright, well, if ABC is a right angle, okay, we need to somehow connect ABC with 1 and 2 and also what it means to be a right angle. Well, if we know it's a right angle, we know that the measure of ABC then is equal to 90 degrees. Okay, and that's by definition of a right angle. We know that we have a right angle that equals 90 degrees. Okay, this is a key point here. Now that I have 90 degrees, I want 1 and 2 to add up to 90. So if there's some way that I could show that, I would be set. If we look at the parts of angle ABC, we could break it down and state that the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Seeing as this is by, we have this little angle here, angle 1, and we have angle 2. We take those and put those together, we have angle ABC. Reason for that? That's the angle addition postulate, right? Two small angles add up to a large angle. Well, now that 1 and 2 equal ABC and ABC equals 90, we can make the statement then that 1 and 2 add up to equal 90. Okay, and what we did there was just substitution. We substituted in the value for the one we wanted. And now we're looking at our proven statement. 1 and 2 are complementary angles. What does it mean to be complementary angles? It means that the two angles add up to 90. We showed that angle 1 and angle 2 equal 90 degrees. So therefore then, we have complementary angles by the definition of complementary angles. Okay, we have shown that 1 and 2 equal 90 degrees, therefore then we can say that they are complementary by the definition of complementary angles. Again, this is a pretty important proof from this section, and you will have to know it in and out for our test coming up. Alright, very good. Let's take a look at our next one. Given angle 1 and 2 are a linear pair, and angle 1 is congruent to angle 2, prove that G is perpendicular to H. So again, we're proving that theorem from this section, so we can't just use the fact that we know that it's perpendicular. We have to show it. Okay, and just like the last proof, we can start with the given. Okay, if we have the given, we can use the given then to direct our proof. I would say if we're trying to show that G is perpendicular to H, we have to show that angles 1 or angle 2 is equal to 90, okay, or is a right angle. Because if angle 1 or angle 2 is a 90 degree angle, or a right angle, then we know that they're perpendicular by definition of perpendicular lines. So I somehow need to show that. I would start with the given, after we've listed it, with trying to show what we can do with it. If we have angle 1 and angle 2 being a linear pair, that means that they are supplementary. Okay, a linear pair implies supplementary. So 1 and 2 are supplementary by the linear pair postulate. That's what it means to be a linear pair. You are supplementary. If you're supplementary, then you would tell me that the angles themselves add up to 180 degrees. So therefore 1 plus angle 2 equals 180 degrees by the definition of supplementary angles. That's what it means to be supplementary. You add up to 180 degrees. You say, okay. Now I've shown that 1 and 2 add up to 180. Now I need to show that either 1 or 2 equals 90. Okay. If I look at my other piece of given that I haven't used, I haven't used the fact that 1 is congruent to 2. Congruency implies equality, so therefore the measure of angle 1 equals the measure of angle 2 by definition of congruent angles. If the measure of angle 1 equals the measure of angle 2, and I'm trying to that means I have no problem replacing angle 1 for angle 2. So I can write the statement that says the measure of angle 1 plus the measure of angle 1 equals 180 by substitution. I'm substituting in the value for 2, the angle of measure angle 2, with the measure of angle 1. So you're saying, why did I do that? Well, just like in algebra, if I think of measure of angle 1 as the variable x, then this one also has to be x. And if I have two x's, I can just put those together. Well, I'm going to do the same thing with the measure of angle 1. So if I have one of them here and one of them here, I really have two of them. So I have 2 times the measure of angle 1 because I have two of those. That equals 180. Alright, by the kind of reverse distributive property. Alright, I've kind of undistributed the value for each one of those. Okay, otherwise simplifying would work. What I can do then is if I know that there's 2 times the measure of angle 1, so there's two of them, I can divide on both sides by 2, leaving me with measure of angle 1 equal to 90, again by the division property of equality. If I know that the measure of angle 1 is equal to 90, then I know that angle 1 is a right angle by definition of right angles. And if I know that angle 1 is a right angle, which is what I wanted to show before, then I know that G is perpendicular to H by the definition of perpendicular lines. So it's kind of a long proof, has many steps, but definitely one that you want to be familiar with for the test. These two proofs, the last one and this one, are focal points on our quiz coming up. Alright, next we're going to talk about distances between points in lines and parallel lines. Alright, let's take a look at the next problem then. It says in coordinate geometry, so talking about the coordinate plane that exists in algebra, same thing. Line S contains points 0, 0 and negative 5, 5. Find the distance between line S and point 1, 5. So what we're going to do here is a pretty intensive algebraic problem, and we're going to find the distance between a line that exists on a coordinate plane and a point that is also in that plane. So let's kind of get a visual representation of what's happening here. If I have a coordinate plane here, an x and a y, so my x-axis, my y-axis, and I plot the points, let's give them some names just so we can label. So we'll give 0, 0, A, negative 5, 5, B, and then V is already given to us. So if I plot my points, I have a point at the origin, 0, 0, negative 5, 5, kind of be, 1, 2, 3, 4, 5, up 5, 1, 2, 3, 4, 5, so we're kind of up here. Alright, we can connect those two dots to make a line. Goes off infinitely either direction. And then what we have is point V. So we have, again, this was A, this was B. We have point V at 1, 5. So we have 1 over up 5 here. This point V. What we need to do is we need to find the distance from point V all the way to line S, which was this line here. To find the distance between a line and a point, or a point in anything, any object, I need to first of all have a perpendicular line to the object. So I need to have a line that goes through V that is perpendicular to S, where the perpendicular line and line S meet, that blue point there, that's the intersection. We'll call that point D. And the true distance between the point and the line S will be the distance formula calculation between point D and point V. So the entire goal is to find point D so that I can use that then in the distance formula with point V to calculate the distance between the point and the line. Okay, several steps that are going to happen here using many different things from algebra. Okay, where do I start with? Or where do I start? I have to first find the equation of the line that exists for line S. So I have 2 points. I have A at 0, 0, and I have B at negative 5, 5. And I need to find the equation of this line. Alright, and to do that, first find the slope. Okay, so we know slope formula. Slope is equal to y2 minus y1 over x2 minus x1. And I would label my points x1, y1, etc. x1, y1, x2, y2. Okay, again, order is irrelevant as long as you're consistent. So in this situation, I would have 2 minus 0 over, excuse me, not 2, that'd be 5. I looked at the x sub 2. I would have 5 minus 0 over negative 5 minus 0. The top one would be 5. The bottom one would be negative 5. Okay, simplifying the slope, 5 divided by 5 is 1, and there's a negative, so my slope of the line will be negative 1. So the slope of this line is negative 1. And as we've done before, we need to take the slope of a line and a point and create an equation from that. So what we're going to do is just take the very first point, 0, 0, because it's the easiest to make an equation from. So we have 0, 0 and a slope of -1. I will use the point slope form. Right, point slope, y minus y1 is equal to m quantity x minus x1. Alright, now a lot of work has to go in for this equation because I have both zeros for the x1, y1. So I have y minus 0 is equal to -1 x minus 0. Simplifying, just have y is equal to -x. So that's my equation of line S. So this is step number 1. I need the equation of the original line. Okay, and I have that now. Alright, the next thing that I want to do is I need to create the equation of a line that goes through my point V and intersects with line S. So what I have is I need the perpendicular slope to my line. Alright, and if my slope is -1, the perpendicular slope will just be 1. And the point that I'm going to use is point V. And point V is at 1, 5. So point V, 1, 5. And I'm going to create the equation of a line that is perpendicular to my original line. So I do again point slope. I have my y minus y1 equals m quantity x minus x1. Here I have a little more work to do, as my x sub 1 and y sub 1 are not just 0. Filling in the information that I know, I have y minus 5 is equal to 1 parentheses x minus 1. I'll distribute, and I have y minus 5 is equal to x minus 1. I will then add 5 to both sides, with my equation being y is equal to x plus 4. That's step 2. I now have my equation of the line that is perpendicular to my original line. So what I have is I have this line here, okay, calculated out. I have this line calculated out. Okay, seeing as has both of those equations use y and they're the same letter, they are actually equal to one another. So I can make the statement that the equation from number 1 and the equation for number 2, since they're both y equals, they actually equal each other as well. And when I set them equal to each other, I'm going to be able to find the intersection point of those two lines, because there is a point that exists where both of the lines cross. So I'm going to take my equation from 1 and equation from 2 and set them equal to each other. So I have -x is equal to x plus 4. So I'm substituting the values in. I have this y here and I have this second y. I set them equal to each other, so I have the -x and the x plus 4, and they're equal to each other. So step 3 here is solving then. What I have is I have 2 x's. I will subtract x on both sides to get the x from away from the 4, and I'll end up with a -2x is equal to 4. Getting x by itself, I'll divide by -2x, and I'm left with x is equal to a -2. Well, I'm looking for a point that is on both of the lines. I have the x part of the point, so I need to find the y part of the point, and to do that I will plug in, okay, this x equals 2, and I'll take the -2 and plug it in for x in my equation here. So if I solve that part of it, I have y is equal to a -2 plus 4 for the ordered pair, or for y equal then to 2. So step 3 then gives me my ordered pair. My ordered pair is -2, 2. And this right here from step 3, if I go back to my original picture, was this point D that I'm talking about. And if we look at the crude graph that I have, it looks like it would be in a spot of -2, 2. Alright? So now I have my point from 3, -2, 2. And now I'm left with the distance formula with my original point that we were searching from, which is V, and V was at 1, 5. So I have 1, 5, and I have my new intersection point, -2, 2, and I need to use distance formula. The distance formula was D equals the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. And I plug in my x and y's, and I'll be left with the equation 1 minus a negative 2, depending on how you line these up, as long as you're consistent, it's okay, plus 5 minus 2, and both of these are squared, all under the square root. Okay, simplifying. 1 minus a negative 2 is really like adding 2, so therefore I have 3 squared plus 3 squared, all under the square root. 3 squared is 9, so I have 9 plus 9 under the square root, and 9 plus 9 is equal to 18, so I have the square root of 18. And I can either leave it as that, give the decimal approximation, or I can break it down into 2 parts, right? Because I can extend the radical, because square root of 18 can be broken down into the square root of 9 and the square root of 2. Square root of 9 is 3, square root of 2. Final answer to this problem, and the distance between point 1,5 and line S is 3 square root of 2, or the approximate value. Okay, and you can use your calculator to find the approximate value. Okay, and that is the steps. Have 4 steps here. We have to first, going up top here, find the equation of the line that we're trying to find the distance to. Have the perpendicular line that goes to the point we're finding. Find the intersection point, and then take the 2 intersection points and find the distance. Okay, in step 4 here, find the distance between the 2 is the final answer. Again, final answer, 3 square root of 2. Alright, let's take a look at find the distance between a point and a line. Coordinate geometry. Line N contains points 2, 4 and -4, -2. Find the distance between line N and point B, which is 3, 1. Alright, the first thing that we have to do is find the slope of line N, and we'll use points 2, 4 and -4, -2. So finding the slope there, we'll take -2 minus 4 over -4 minus 2. We'll set that equal, then to what it equals, -6 over -6, which is equal to 1. So our slope is 1 for that line. I'm going to pick the first point given as the point that I'll use to find the equation of the line. So given a slope equal to 1 and a point 2, 4, we will now plug it into point slope form. So we'll have y minus 4 is equal to 1 quantity x minus 2. Distributing here and solving, we have y minus 4 is equal to x minus 2. Add 4 to both sides, and we will have y is equal to x plus 2. So that is, we'll put a little number 1 by it, that is the equation of the line N that we're working with. The next thing we need to do for part 2 is we need to take the perpendicular slope to line 1 and have that line go through point 3, 1. So perpendicular slope to line 1 will be a -1. Flip the fraction and change the sign. If we go up here, again 3, 1 is our point from B, so I'll have 3, 1. Put in the point slope then and solve. Y minus 1 is equal to -1 quantity x minus 3. Distributing, y minus 1 is equal to -x plus 3. And when we add 1 to both sides, then we'll have y is equal to a -x plus 4. Alright, and this is equation number 2. Equation number 2. Alright, my third step then is to take my equation from number 1 and my equation from number 2 and set them equal to one another. So I will have 1 equaling 2, and I have x plus 2 is equal to a negative x plus 4. And then I will go ahead and combine like terms and solve. So I'm going to add x from the left to the from the right to the left. So I'll have 2x plus 2 is equal to 4. I'll subtract 2 on both sides. I'll have 2x is equal to 2. Divide by 2 on both sides. X is equal to 1. Now that I have an x equals, I can go ahead and replace x in one of the y equations. I'll do that here. And when I do that, I have y is equal to a negative 1 plus 4. Therefore, y is equal to positive 3. My ordered pair for my intersection point then is at 1, 3. And this is the point that I'm going to use in the distance formula to solve. So I now need to find the distance from point B, which was 3, 1, and my new intersection point, which is 1, 3. So step 4 here, distance formula, I have 1, 3 and 3, 1, which was point B. Alright, plugging it in for the distance formula. We have d is equal to, we have the square root, and we have our x's, they need to be subtracted from one another, so we have 1 minus 3 squared plus our y subtract from each other, 3 minus 1 squared. 1 minus 3 is negative 2. Negative 2 squared is 4. Plus 3 minus 1 is 2. 2 squared is 4. Still the square root of all that. So we have equals the square root of 8, which can be broken down into the square root of 4 and the square root of 2. So final answer is 2 square root of 2. And then also you guys can find the approximate value to that. Alright, moving further from this problem then, let's take a look at the next one. Alright, this one's a little different. It says, find the distance between the parallel lines A and B, whose equations are y equals 2x plus 3 and y equals 2x minus 1. Let's just show representation of those two. If I had 2x minus 1, I have my point at negative 1. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and left down 2 over 1, down 2 over 1. So here is one of my lines. My second line here I'll draw in red, 2x plus 3, so I have 1, 2. My intercept is at 3, and I'm going to do the same thing, up 2 over 1, down 2 over 1, down 2 over 1, 2 over 1, 2 over 1. So I have the red and I have the blue lines. I went off there a little bit. The red line, those are my two parallel lines. I need to find the distance between those two lines. The difference between this problem and the last one is that I need to pick a point to start with on one of the lines to find the distance of. I'm going to pick the second equation here. I'm going to pick the intercept of that second equation. So the intercept, or the y-intercept, is negative 1. So the ordered pair that I'm going to use is 0, negative 1. I chose that from the second equation. And now I need to formulate a line that goes through that point that is perpendicular to both of these lines. Then I can find the intersection and then do the distance formula like the previous problem. So I know the point that I'm going to use, it's 0, negative 1, and I now need to write an equation of a line that is perpendicular that goes through that point. So since the slopes here are 2, the perpendicular slope will be negative 1/2. And now that I have a slope and a point, I can go through and just write an equation of the line that creates the two intersection points. Okay, so the new one, I just drew the blue one right there. So putting in y point slope, I have y plus 1 is equal to a negative 1/2 quantity x minus 0. Solving that, I have y is equal to a negative 1/2 x minus 1 when I bring over the 1 from the left to the right. So I'm going to call this equation star. Now that I have equation star, the next step is to take the starred equation and set it equal to the equation that I did not use for the ordered pair in the beginning. So that would be the second one here. I'm going to set those two equal to each other. I'm going to call that equation number 1, and I'm going to take 1 and set it equal to star. So I have negative 1/2 x minus 1 equal to 2x plus 3. Alright, combining like terms and solving here, I'm going to add 1/2 x to the right, and I'm going to subtract 3 to the left. So I'm going to have negative 4 is equal to 5/2 x, right? Because 2.5 converted into improper fraction is 5/2. So I have negative 4 is equal to 5/2 x. Solving for x, then, I need to multiply by the reciprocal. So I have x is equal to 2/5 times negative 4, right? And that's going to equal my x value. And 4 over 1, negative 4 over 1 is really what I'm multiplying here. So I have a negative 8/5. So my x value is a negative 8/5. I need to plug that x value into a y equals equation to get a y value out. I'll do that here. So I know that I have y is equal to negative 1/2 quantity negative 8/5 minus 1. Multiplying straight across with fractions, I have a positive 8/10, which can be broken down into 4/5, and I have 4/5 minus 1, and 4/5 minus 1 will give me y equals a negative 1/5. So my ordered pair that I have for the intersection point is negative 8/5 comma negative 1/5. And the point that I'm going to use with it in the distance formula was the one I chose earlier, 0, negative 1. So I have my 0, negative 1 here. And now I will solve using the distance formula. So again, d is equal to the square root. I have to subtract my x's from each other. So I have 8/5 minus 0 squared plus a negative 1/5, and the negative 1 becomes a positive 1 squared. Negative 8/5 from 0 is just a regular, it doesn't change, negative 8/5 squared plus a negative 1/5 plus 1 gives me 4/5 squared, all under the square root, equals here. Now when I square, I need to square both the top fraction and the numerator and the denominator, so therefore I'll have 64 25ths plus 16 25ths, all in the square root, which equals 80 over 25, all in the square root. Excuse me, square root. I can break that down into the square root of 80 over the square root of 25. The square root of 25 becomes just 5, and I'm left with that square root of 80 on the top. And with that square root of 80 on the top, I can go ahead and simplify that further, and I can break that down to the square root of 16 square root of 5 over 5, which leaves me the final answer of 4 square root of 5 over 5. Final answer. 4 square root of 5 over 5, and then the approximate value that you guys can find as well. Alright, this ends lecture for today. Problems that we're going to be practicing are going to be on page 219, numbers 15 through 29. Thanks.